This video is going to be about finding the greatest common factor of two whole numbers less than or equal to 100. Let's review a few vocab words. Factors. Factors are numbers you can multiply together to get a product. So for instance, if I have 2 times 3, that equals 6. I can say that 2 and 3 are factors of 6. Now the greatest common factor of two numbers is the greatest factor shared by those numbers, which we will get to throughout this video. Now, if we look at the example below, factors are numbers that divide evenly into a number. So for example, 4 is a factor of 24 because 24 divided by 4 is 6, and then 6 times 4 is 24. Therefore, 24 is divisible by both 4 and 6 because 4 times 6 is 24. So we can say that 24 definitely has factors 4 and 6. 24 has a lot more than that, but that's just an example. This question is a perfect example of when we use the greatest common factor to help us solve problems. Let's take a look at this question. There are 12 boys and 18 girls in Miss Ruiz's class. Each lab group must have the same number of boys and the same number of girls. What is the greatest number of groups Miss Ruiz can make if every student must be in a group? Well, let's see. If we look at the number 12, we have 12 boys standing in the room, and we have 18 girls standing in the room. So we need to think about a number that when we divide both of these numbers by, we will get the groups. So let's look at the factors of 12, meaning what numbers can I divide 12 by? And then we're going to look at the factors of 18, which is another way of saying what numbers can I divide 18 by? And then we want to find a common number. So 1 times 12 is 12. I like to use the rainbow method to help me connect the factors. 2 times 6 is also 12. Can 3 go into 12? Yep. 3 times 4. And then there's nothing in between 3 and 4, so we know we're done here. So 12 has 1, 2, 3, 4, 5, 6 factors. 18, 1 times 18. 2, well, I know 2 times 9, and 18 is an even number, so I know 2 has to be a factor. 2 times 9. 3 is a factor of 18. I also remember my tricks, my divisibility tricks. If I take 18 and I add the digits 1 and 8, I get 9. If 9 is divisible by 3, I know the whole number is divisible by 3. Anyway, 3 times 6 is 18. Can 4 go into 18? Nope. 4 times 4 is 16. 4 times 5 is 20. So no. 5 can't go into 18 because it doesn't end in a 0 or a 5. And 6, we've already established that 6 is a factor. So once we start repeating, we know we're done. Now 18 and 12 have 1 in common, 2 in common, 3 in common. They do not have 4 in common. They have 6 in common. And then they don't have anything else in common. So their common factors are 1, 2, 3, and 6. The greatest common factor would be 6, which means we could take 12 boys and divide that into groups of 6. So 12 boys divided into 6 groups would be 2 boys in a group. And then we can take the 18 girls and divide that into 6 groups, and that would mean there were 3 girls in a group. So this teacher, when she gets 12 boys and 18 girls, she knows that the greatest amount of groupings she can have is 6. She can have 6 tables. And she knows she's going to have 2 boys in each group and 3 girls in each group. So each group is going to have the same number of boys and the same number of girls. Okay, 2 boys in each group, 3 girls. Now she could also group the kids into groups, 3 groups, then there would be more boys in each group. But she wanted to get the greatest number of groups. And when we see the greatest in the word problem, the greatest number of groupings, we know we can use the greatest common factor. Using your knowledge from class and from the previous screen, why don't you try this question on your own? Press pause on the video. Try to find the greatest amount of hand warm packets and foot warming packets will be in each welcome kit. So what's the greatest number of welcome kits that the ski members can create? So take a minute to try this on your own. Then press play and the answer will be up and you can self-assess. Okay, so you should have written out all the factors of 60 or the pairs of numbers that when multiplied together make 60, as well as the factors of 48. And in other words, all the factors that when multiplied together make 48. I used the rainbow method to keep track, and then I circled all the common factors. So some of the common factors are 1, 2, 3, 4, 6, and 12. Now keep in mind, 1 will always be a common factor, so you don't always have to write it or circle it, but most people tend to do so just so they can stay organized. So what's the greatest common factor? The GCF is 12. So these ski club members, if they're preparing these welcome kits for new skiers, they know that they can make 12 kits that would have the same amount of hand warmers and foot warmers in each one. So they can make 12 groups. Now, how many hand warmers would be in it? Well, if you have 60 hand warmers, and you divide that by 12, you know you're going to have 5 in each packet. If you then have 48 foot warmers divided by 12 welcome packets, you'll have 4 of those in each one. So each packet's going to have 5 of the hand warmers and 4 of the foot warmers. So that's how we use GCF when dealing with a real-life grouping situation. Let's sum up this video. Essentially, 2 numbers that when multiplied to produce a product are called factors. For example, 4 and 9 are factors of 36 because 4 times 9 is 36. The greatest common factor of 2 whole numbers is the greatest number that is a factor of both of them. And as you can see from those 2 real-world problems, we can use the greatest common factor to find the greatest number of groupings of people or things. Now what we'd like you to do is go to the next screen for independent work. Complete following questions on your own, and depending on what your teacher would like, you can bring your answers into class and we can go over them. Hope this video was helpful, and remember to watch it as often as you'd like.